નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 10th, Subject Science, Chapter 12, Electricity. So, dear students, electricity terms you have listened many times. So, this term, without electricity, it is a part of our life also. So, without the electricity, our life will be inconvenient. Correct or what? So, electricity has an important place in the modern society. So, all the luxurious items will be run by the electricity. So, it is a controllable and convenient form of energy. Controllable also and convenient form of energy for variety of users in homes, schools, and hospitals. So I think you have to search which place it will not be. Correct or not? So many users will be there. So now, what constitutes electricity? How does it flow an electric circuit? And what are the factors that control or regulate the current through an electric circuit? So these are the things you are going to learn. See, electric current and circuit. First of all, we will see that the electric current means what? See, you know that, okay, for example, this is the battery. Just I will give this is the battery. Okay, here this wire is attached with this battery. And you know that here, okay, switch will be there. And here bulb will be, the bulb is glowing. Okay, like this we have done one circuit. So now you know that now, whenever this circuit, see, this is the switch, this is the cell. See, through this cell, this is we are saying conductor wire. So when you switch on this bulb will be glowing. This is the source, energy source is this one. The cell is the energy source we are calling. So when you switch on, this what will happen? This electron, from these electrons are moving. Or electricity we are saying, no, electricity is moving. So means here electrons will move. These electrons contains charge also. This electrons contains charge particles. This flow of charge of electrons, so that we are calling electric current. So what are the idea, students? This flow of electrons or flow of charge of electrons, we are saying electric current. And this is the circuit. Okay, in this way, so you got the heading electric current and circuit. So we are familiar with the air current and as well as water current. Air current, water current. So we know that flowing water constitute the water current in the rivers. So flowing of the water creates the current. That means what? Flow of charge. Similarly, if the electric charge flows through a conductor wire, see, similarly electric charge flows through the conductor and, for example, through the metallic wire. So this is what we are saying, metallic wire. We say that there is an electric current in the conductor. So what we are saying? There is an electric current in the conductor. So in a torch, we know that the cells, or we are saying a battery, when placed in the proper order, provide flow of charges or an electric current. This flow of charges, what we are saying? An electric current through the torch and bulb will glow or bulb to glow. So we also seen that the torch gives light only when it is switched on. So when it is switched on only, the light bulb will be glow up. Okay. Otherwise, now a switch makes the, say, dear students, what does a switch do? So what does the switch doing? A switch makes a conducting link between the cell and the bulb. So the switch makes the conducting link between the cell and the bulb. Okay. So a continuous and closed path. See, this is the closed path we are saying. Okay, continuous and closed path of an electric current is called as electric circuit. So what you are saying, dear students? A continuous and closed path of an electric current is called as an electric circuit. Now, if the circuit is broken, okay, suppose if the circuit is broken here, so you see, if the circuit is broken or anywhere or switch off the torch is turned off, the current stops flowing and the bulb does not glow. If it is broken in anywhere, the current does not flow. Okay, got the idea, students? Now, next one. How do we express the electric current? So, what is the definition for the electric current? See, electric current is expressed by the amount of charge flowing through a particular area in the unit time. So, that is called as electric current. Okay, electric current means the amount of charge flowing through the particular area in the unit time. So, that is called as electric current. Or you can say like this also, it is the rate of flow of electric charges. Or you can say in other words, it is the rate of flow of electric charges. However, in circuits using the metallic wires, see, this is, you know that, so this is a metallic wire. So this is the metallic wire. Electrons constitute the flow of charges. So electrons will be there. See, dear students, see, we see the metallic, okay, this is the metallic wire. And this we are cut here, so this is this one here. This we are saying the section of the particular part. And this section contains, this metallic wire contains what will be there, dear students? Atom will be there. How? The atom, metal atom positive charge. So what will be there? In this section, you will see that this is in the positive charge. Okay, these metal atoms are in the positive charge. And this one losing the electrons. So what will be there? This one is losing the few electrons. So that we are saying the free electrons. Here these free electrons will be there. So when you switch on the current, these free electrons are moving in the particular direction. So like this way, in the unit direction we are saying, or in the unidirection. So that is we are saying the flow of electric current. Okay, this flow of electrons this side. But actually here you will know that the current flow is this direction. So why, and we will discuss later. Okay. So in circuits, using the metallic wires, electrons constitute the flow of charges. However, electrons were not known at the time. So electrons were not discovered at the time when the phenomenon of electricity was first observed. So electric current was considered to be the flow of positive charges, and the direction of the flow of positive charges was taken to be the direction of the electric current. So that is why this direction they have taken as flow of the electric current. But conventionally, in an electric circuit, the direction of the electric current is taken as opposite to the direction. This opposite to the flow of electrons, they have taken the flow of the electric current. Okay, direction of the flow of electric currents, so which are negative charges. So actually whenever electrons move in this direction will go, but because before that the electron was not discovered, so that time the electric current flow is given from that side to this side. So that is why the flow of current what direction will be given, this direction. Okay, conventionally in an electric circuit, the direction of the electric current is taken as opposite to the direction of the flow of electron here, but this is opposite to this flow. Okay. Now, if a net charge Q flows across of any section, so that is why the formula will say, so electric current is denoted by I. Electric current is denoted by I. is equal to Q upon T. So Q upon T means this charge per unit time, charge per unit time. Or you can say that the current is rate of flow of charge per unit time. So that is called as electric current. So denoted by I, and Q is the charge. Okay, time you are knowing also. Now you see that the SI unit of electric current is Coulomb, Coulomb. This is denoted by C. Okay, Coulomb you are saying, which is equivalent to the charge contained nearly by C. 1 Coulomb is equal to 6 multiplied by 10 raised to 18 electrons. Okay, these are all important points you have to remember, dear students. So we also know that 1 electron is equal to 1.6 multiplied by 10 raised to minus 19 Coulomb. So 1 electron is equal to 1.6 multiplied by 10 raised to negative 19 Coulomb. Okay, the electric current is expressed by a unit called ampere. So what you are doing? Ampere, A-M-P-E-R, or denoted by the small letter here. A will be there. A we are using ampere. Okay, named after the French scientist Henri Marie Ampere. Henri Marie Ampere. So during the year 1775 and 1836. So 1 ampere is constituted by the flow of 1 coulomb of charge per second. So 1 ampere is equal to, what you are saying? By the flow of 1 coulomb. So 1 ampere is equal to 1 ampere is equal to 1 coulomb 1 C upon S 1 second. 1 C upon 1 coulomb upon 1 second, or per second you can say. Okay, now small quantities of current are expressed in the milliampere also. So 1 milliampere is equal to 10 raised to minus 3 ampere. 10 raised to minus 3. Or micrometer. 1 micrometer is equal to 10 raised to minus 6 ampere. So this is all you have to remember, dear students. An instrument called ammeter measures electric current in a circuit. So what is what you are saying? Ammeter. This is an instrument measures the electric current in the circuit. It is always connected in the series in the circuit. See, you will learn the next video. So here, connected service means what? This is like this. So in the series you are saying. Okay, so we'll learn the series connection and parallel connection later. But this type of will be in the series connection you are saying. Okay, shows in the diagrams also say circuit. It is always connected in the series in a circuit through which the current is to be measured. Okay, now, so dear students, now you will see that a question here. A current flows, a current of 0.5 ampere drawn by the filament of an electric bulb for 10 minutes. Find the amount of the electric charge. So what you have to find? Find the amount of electric charge. So here you see what is given here. You see what is given for you. See, you are given here electric current. I is given 0.5 ampere. What is given? 0.5 ampere. And time is given. Time is how much? Minutes is given 10 minutes. So you know that 10 minutes you have to change in the second. So automatically it will be 600 seconds. And now what you have to find? You have to find the charge. So you know that electric current formula you are knowing. I is equal to Q upon T. So now we are finding the charge. So Q is equal to I multiplied by T, or IT. So now, so multiply it and you will answer what you get. 0.5 multiplied by 600. So answer you will get in the column. So answer you will get 300 coulomb. So this way you can find the answer. So dear students, you should know this important formula is electric current is equal to I is equal to Q upon T. Or if you want to find the charge, then Q is equal to IT or I multiplied by T. Okay. So these are the important points in this video or in this topic. Now next we will discuss in the next video electric potential and potential difference. Okay students, thank you, bye bye.
Thank you for joining us.